Okay, this chapter is matrices. We will be talking about what is a matrix, and what are matrices, how do we add, how do we subtract, multiply, divide, and so on and so forth. So let's first of all understand what is a matrix. Matrix is a rectangular arrangement of numbers which can be arranged in the form of rows and columns. You can see the example here. Say if we are writing two data together, that is 5 and 1. So we can say it is in a column here. So we call this also as a matrix. It can be in columns, two columns here, one column here, another column here. We know that vertical lines are columns and the horizontal lines are called rows. So vertical lines, vertical column, 5 and 1, 3 and 2. Or we can take it in this manner, that is rows, 5 and 3, first row, first 1 and 2, second row. First column is 5 and 1, second column is 3 and 2, like that. So rows and column, when we write those in, say this is the rectangular bracket within which we write all the elements, maybe one element here, another element here, another element here, like that. So we call this arrangement of numbers or any element in it, we will call that entire thing together as a matrix. You can see some examples here. Another one is one row, 5, 3, 2, no column in it. And the word matrix is basically a singular of matrices. So the plural of matrix is matrices. When we have more than one, we call those as matrices. But basically when we talk about this entire thing is called one matrix, another matrix here, like that. So both of those together will be called matrices here. And the elements in it, say the entity in it, right? We call them, say the content of this particular matrix is called an element in it. In a matrix, there are horizontal lines and which we call as rows, and vertical lines that we call as columns. I already explained that to you. So which is there in it. Now comes order of matrix. What is the order of matrix? Fine. So you can see in this case we have got 1, 2, 3. So 3 elements are in a row. It's a row. Another row. So how many rows are there? One row and another row, 2 rows. How many columns? 1, 2, 3 columns again. So we can write this in the order we can write. The order of the matrix is, right, first we write the number of rows. How many rows does it have? 1, 2 rows. So it will be 2. And how many columns? 1, 2, 3. So 2 into 3. This matrix is 2 into 3. The order of this matrix is 2 into 3. Okay. Fine. So first we write the rows and then we column. You can see they have given the order is 2 to 3. Or we can read it by 2 by 3 also. Not 2 to 3. I'm sorry. We don't call is 2, but 2 by 3 we can call it as. Now, while stating the order of the matrix, the number of rows is given first and then number of columns. I mentioned already there. Elements, I already spoke to you that whatever the content, the entity of that particular matrix is called element. Element is 2, 0, 4, 1, minus 3, and 2. They are all elements in it. Since a matrix A has got 2 rows, 1 and 2 rows, so and 3 columns, we call it as 2 by 3. Okay. And the number of elements will be how much? 6. You can count 1, 2, 3, 4, 5, 6. Or you can say 2 rows and 3. So multiply the 2, you will get what? 2 into 3 is 6. So 6 elements are there in it. 1 row and 6 columns will be what? 1 to 6. That is 6 elements. 2 rows and 3 columns will be 6 elements. 3 rows and 2 columns will be 6 elements. And 6 rows and 1 column will be 6 elements. You know how to get it. Then we come to a type of matrices. What are type of matrices? One is called row matrix. Row matrix. What is row matrix? It has only one row, that's it. If it has a matrix which has got only one row, is called row matrix. Example is, you can see AB or ABC is a row matrix. It will always be in the order of 1 into 2 or 1 into 3 or 1 into 4, like that. Okay, because the row we write first and the column we write the next. Right, a row matrix is also called a vector matrix, also row vector also. What do we call it as? A row matrix is also given a name as row vector. The word is vector. Which one? Row matrix is got. Okay. Then come column matrix. If it has only one column, you can see there is A and B. Nothing to know about more about this. So the order will be what? Remember there are 2 rows in it, so it will be 2 into 1. Okay, 2 by 1 we can call it as. So it has only one column. Maybe it has can only two elements. It can have 3 elements, 4 elements, no problem. And the other name for this particular column matrix is column vector. What do we call it as? Column vector, row vector, and column vector here. Understood? Now comes here square matrix. The word is square. What is square? Length and breadth are equal, right? So if these all the sides are equal, it's a square. So same way here, means if it has 2 rows, then 2 columns, then it will be a square matrix. Or 3 rows and 3 columns of the square matrix. So we call it 2 by 2 is a square matrix. Order will be 2 by 2 is a square matrix, or 3 by 3 also will be a square matrix. Even 4 by 4 also will be a square matrix. The number of rows and number of columns are equal in it. Okay, equal number of rows and equal number of columns. Now rectangular, in which the number of rows and number of columns are not equal, will be rectangular. Here it is 2 row and 3 columns. So 2 into 3 here, 3 rows and 2 columns. It will be 3 into 2. So we call this as a rectangular matrix in which the number of rows and number of columns are not equal. Then comes zero or null matrix. Means if the elements, okay, each element of the matrix is 0, we call that as a zero matrix or null matrix. It's not that, it can be have any one. So here 0 0 0 0 0 0 and 0 0 0. Fine, this is also a null matrix with all the elements in it are 0, right? So it's called a zero matrix, or also called a null matrix. Then come diagonal matrix, when we have the elements only in the diagonal form. Square matrix, in which all the elements are 0 except those in the leading principal diagonal, okay, called diagonal matrix. For example, you can see that if you draw a diagonal here, the elements are only in the diagonals, nowhere else. Here the elements are only the diagonals. That will be called as a diagonal matrix. Then the next one is unit or identity matrix. A diagonal matrix in which each element is a leading diagonal is only unity, means 1. So here we have got diagonal matrix because the numbers are not 1. If it is only 1 1 here at the place of these elements, the numeral elements, which is 5 minus 2 and 3, then it will become a unit matrix. So diagonal matrix, right, in which the elements in the diagonal part is only 1. So 1 1 1 1 1 like that. So this is a unit matrix. Now comes transposition of matrix. Basically, what does it mean? When we have got 2 rows here and 3 columns, so what we can do is we can convert it into 3 rows and 2 columns. Just convert it. Say 2 is 2 by 3 was originally, this was 2 by 3. If I convert this order into 3 by 2, so we say that we have transposed it. And how to do that? Simple. You write this first row here as a column. You can see that 2 will be at the top, 3 will be the next to it, and 1 is this one. And this will be go to the 0 here top, middle, and then 7 go like that. Okay. So if you just make the rows as column and column as rows, you have changed the you have made it a transpose the matrix here. So transposition is what? Converting the order here. 2 is to 3, 2 by 3 will become 3 by 2 here. Okay, so easily you can understand and do it. Two matrices are said to be equal if both the matrices have same order, number 1, and both the corresponding elements are equal. See, we cannot have, like, say for example, this is 2 1, I'm writing it here, 2 1 3 and 5. Okay, and we have got here 2 1 3 5 and 3 2. See, the order is 2 is to 2 here, 2 into 2, and here is 2 into 3, number 1. So if the order is not same, then we cannot say the two matrices are equal. Order is same and then the elements are also same, then only it will be the same here. Clear? You can see the order is 2 into 2 and here is also 2 into 2. Then it means the first line is done. Second, it says the corresponding elements of both the matrices should be equal. It has 2, it also has 2, it has 3 3. Second row 1 1 5 5. Then the two are equal matrices. Okay, then comes how to add matrices. So remember one thing here, if the two matrices are in same order, then only we can add or subtract. Fine. Two matrices can be added together if they have the same order. Very important one. If they don't have the same order, we can't add it. How do we add? We add the each element. So for example, there is a matrix A, which is this one, matrix B, which is this one. Same order, 2 into 2, 2 into 2 here, 2 by 2, 2 by 2 here. So first element is 2, first element of the corresponding is 3. So 2 plus 3 will be 5. Then 1 and 2, 1 plus 2 is 3. Then 5 plus 1, 6. Then 6 plus 4, 10. So this is how we add them up. Simple. Then comes subtraction. Again, this is possible only when the two matrices are of the same order. Here this is 2 into 2 by 2 and this is also 2 by 2. Then only possible. If it is 2 by 3 and 2 by 2, not possible. Subtract 5 minus 3, 2. 4 minus 0, 4. 2 minus 4, minus 2. 1 minus 2, minus 1. So this is the resultant here, A minus B. Okay, clear? Next come additive identity. So yes, A plus B was here. When we add the two matrices, A minus B is this one. By subtract the matrices here. Next is additive identity. Remember, we had done what should be added to a number so that we get the same number, and that number is supposed to be called as what? Additive identity. So basically identity is not lost, right? So there is a number 3. I don't want this identity to be lost. Means what is identity? Means 3. I want that to be remain the same even though we have added something in it. So what should we add? If I add 1, it becomes 4. It's different from 3. So okay, 1 is not the additive identity. Then what do? We need to add 0 to it so that what do we get? We get the same 3. So identity of 3 has been restored, not changed. So we call 0 as a additive identity here. Same applies here. What should be added here to a matrix so that it remains the same? So we know that we can add a null matrix to it. When we add a null matrix, it will remain the same. For example, this is 4, 6, 0, 7. What should we add to 4 so that remain 4? 0. What should we add 6 to remain 6? 0. What should we add 0 to remain 0? 0 only added. What should we add to 7 to remain 7? 0 only. So this is we call it as additive identity here, right? Same way, what should be added to this one? Null. Remember, we have to add null matrix to any matrix so that remains the same. So null matrix is the additive identity of all the matrices, we can say. Okay. Now comes here additive inverse. Now here, what should be added to 3 so that we get 0? Means we get 0. Remember that one. We should add 3 minus 3 to it. 3 minus 3 is 0. So remember, when we have to calculate or find out the additive inverse of a matrix, so each element will the sign of each element will become opposite to what it is there in the previous one. For example, take an example here. A is having 2 rows, 4 and minus 2, minus 3 and 7. Then what should we add to 4 so that we get 0? So we should add minus 4 to it. What should we add to minus 2 to get 0? Plus 2. What should we add minus 3 to get 0? Plus 3. What should we add to 7 to so that we get 0? Minus 7. So remember, this sign changes, or we can say multiply with minus 1, you can say, right? So multiply everything with minus 1, or say sign will change. So additive inverse of A is this one, right? And if I add the 2, we'll get what? 0 in it. Simple. So, right. If A and B are two matrices of the same order, that the A plus B is equal to B plus A is equal to null matrix, then A is said to be additive inverse. Okay. So what do? We get the inverse of that. What should be added to it so that we get 0? That is the logic that we have to use in it. Next comes here. If O is the 0 or null matrix of a same order as the matrix A, then A plus O is equal to O plus A is equal to A, right? And A plus minus A is equal to minus A plus A is equal to 0. So basically it says what? When A and B are two matrices of the same order such that A plus X is B, then X will be equal to B minus A. You just leave it here, remove the other side, what will happen? So X will be equal to B minus A. So this is what we have to say. For example, the question comes just like this. Okay, what should be added to matrix A so that we get matrix B, right? Then how to get that? You will subtract A from B, and whatever that you get as a matrix, that will be the value of X, and that is here, that is what's supposed to be added to A, right? Clear? Simple question. It will be more clear once we solve some questions based on it. Next comes how to multiply a matrix with a scalar, means a real number. Say for example, we have to multiply any matrix with say 2, 3, 4, a half, -2, -3. Then it's a very simple one. See, it's matrix 4 and 1 has been multiplied with 3. So 3 will multiply with 4 and 3 will also multiply with 1. So 3 into 4 is 12 and 3 into 1 is 1. 3 only, right? So the resultant of these two, number and the matrix, is 12 and 3 here. What should we multiply? Okay, what is the next one? 2 multiplied with this matrix 6 comma 6 minus 4 and 2 0. 2 will multiply with 6, 2 will multiply with 2, 2 will multiply with -4, 2 will multiply with 0. 2 6 are 12, 2 4s are 8, in fact -2 -4, 2 2s are 4, and 2 zeros are 0. So this is how you multiply it. Simple. Next comes here multiplication of matrices. Now one matrix will multiply with another matrix. So remember, two things are important in it: the order here. Two matrices A and B can be multiplied together to get the product matrix AB if and only if the number of columns of A, what is A here? This is column of A, 2 columns, is equal to number of rows of B. So how many rows does it have? 1 and 2 rows. So remember, number of columns of A should be equal to the number of rows of B. Otherwise we can't multiply. Remember this part, and it will come more clear with practice here. See, take an example here. We have got a matrix 3 4 and 5 0, 1 3 and 2 4. So what is the number of rows in it? 1 and 2. What is the number of columns in it? Number of columns in A is how much? 1 column and second column. Number of rows in the second one is what? 1 row and second row. Then yes, the number of column here is 2 and number of rows is 2. So yes, it can multiply. How do we multiply? So first take the first row in it. First row, and what is the first element of the first row? 3. 3 will multiply with, take the first row and take the first column. So if we have got, you can see if the number itself, this first one will multiply with this one, and then this will multiply with the second one. Means the first element of the row will multiply with the first element of the column. First element of the second element of the row will multiply with the second element of the column here, and then whatever multiplied, whatever the product, that we will add them. So 3 into 1 is 3, and 3 4 3s are 12. Add them up. So 3 into 3 into 1 is 3, and 4 3s are 12. 12 plus 3 is 15. So you wrote 15 here. Same way we will come to this one. We will multiply it with this other one. 3 into 2, 6, and 4 into 4, 16. 16 plus 6 is how much? 22. So see, you will write it here. Second part. Okay. So you will write it here, 22. Now then what we will do? We will do the same thing again with this one. 5 into 1, 5. 0 into 3, 0. So 5 plus 0 is how much? 5. So we will write it 5 here. Then 5 into 2, 10. Okay. And then 0 into 4, 0. So 10. Okay. So see, we will multiply this first element of the row with the first element of the first column, second with the second, add them up, it will become the first element in the row here. So this is how you can see we got here 15 22 5 10. So finally we'll get here 15 22 5 10 here. Understood? So first element of the row into the first element of the column of B, added together, and then first row of the element, okay, and the second element, second column, okay, will multiply and add them together. Second row, first element, first column, second row, second column, and add them up. This is how we get it. It will be clear with practice. In matrix multiplication, the unit matrix I here is known as identity matrix. Means what should we multiply with A matrix A so that we get the same? The answer is yes, unit matrix. If you multiply any matrix with a unit matrix, what is unit matrix? We have done that. Unit matrix is always, if you this square matrix, it's say 1 and 1, okay, 1 and 1, and remaining will be 0. Diagonally it should be 1, and we call unit matrix. So if we multiply, see what will happen in it. Multiply with this one with, okay, 2 into 1, 2, and 3 into 0, 3. So 2 plus 0 is what? 2. Then, okay, 2 into 0, 0, and 3 into 1, 3. 0 plus 3 is 3. Then 4 into 1, 4, and 6 into 0, 0. So 4. And then 6 into 0. Sorry, 4 into this one, we did it, right? 4 into 1 and 0. Now, 4 into 0, 0, and 6 into 1, 6. So it is 6 here. So if you multiply with any unit matrix, you will get the same number. You can see 2, 4, 2, 4, 3, 6, 2, 4, 3, 6, same thing, right? But if you multiply here, yeah, the other way around, that is unit matrix, okay, identity right here with the matrix here, then you will also get the same thing, 2, 4, 6. So 1 into 2, 2, and 0 into 4, 0, so 2, right? 1 into 3, 0 into 6, 3, 0 into 2, 0, 2, 1 into 4, 4, 0 into 3, 0, 1 into 6, 6. So we get the same thing. So we'll get the same. Remember, any unit matrix is multiplied with any matrix here, right? You will get the same matrix, or it's commutative, we can call it as. Fine. In order of matrix A is m cross n, means m by n. Then the order of matrix B is, and the order of matrix B is n cross p, means n by p. Then the product AB is possible, right? Matrices are conformable or compatible for multiplication, then only it will happen, as the number of columns of the first matrix A are equal to the number of rows of the second matrix B, right? So remember, columns of the first matrix A is equal to rows of the matrix B in it. You know, it changes. If it is here, the order of product of C, the order of product of matrix C obtained is m cross p, means m by p here. You can see m by n and n by p, so you will get m by p here, okay, m by p. Just telling you, for example, there is matrix first one, 3 rows and 5 columns, 3 into 5, 3 by 5. Another matrix which is 5 by 2. Then you can see there is a 5 and 5 common here, so we will not take 5. So it will be the product of A and B here will be 3 order 2, 3 by 2, 3 by 2 here. So AB, if it is 4 cross 3 and 3 cross 2, or we can say 4 by 3 and 3 by 2, so 3 3 is same, so 4 by 2, so it will be, product will be 4 by 2 here. Take an example. You can see this is how many rows? 1, 2, 3, and how many columns? 2 columns in it. Sorry, 1 column in it here, right? So this is 3 by 2, and here it is 2 by 1. Okay, so you can see that both have got the number of columns the same. Now, so the product will be 3 cross 1, 3 by 1. The product will be 3 by 1. You can multiply and see. 2 into 1 is 2, right? 0 into 3 is 0. So 2 plus 0 is 0, 2 only. Then 5 into 1 is 5, and 3 into 3, 9. So 5 plus 9, 14. 4 into 1 is 4, and 3 into 1 is 3, 7. So what do we get? The row is 1, 2, 3, and column is 1, so 3, okay, by 1. So remember, this is what they have proved here. Okay, for any 3 matrices A, B, and C are compatible with multiplication, then if they are compatible, then ABC means A into B into C is equal to A into B into C. So we can first multiply B into C, and then whatever comes with that you will multiply A. Similarly for BAC, you multiply AC first, and then whatever comes you multiply with B. Or if CAB, you multiply AB, A and B matrices first, and then whatever you get as a matrix you multiply that with C here, so on and so forth. Remember, it's not commutative. A into B is not equal to B into A. There is a matrix A and matrix B. You multiply the two and multiply B into A, you will not get the same thing. Is not commutative. Same way goes here, A, B and C, right? And here, okay, A, B and C, we can multiply AB first, and then whatever comes we can multiply with the C matrix, or we can multiply B and C first, whatever comes to multiply with the A matrix. Is okay, associative, it is possible, but commutative is not there. Okay, A matrix cannot be equal to 0 if A is not equal to 0 and AB is equal to AC, right? Then it is not necessary that B will be equal to C here. I mean, it will come with questions, right? Means you can see A and A can get cancelled and B is equal to C. Not necessary. The word is not necessary. Okay. Then A into B is 0. Then it is not necessary that A is 0 or B is 0. Not necessary. Remember, if A is 0, B is 0, then AB is equal to 0 or is equal to BA. That is okay, because both will be 0 in that case. A into B plus C is equal to AB plus AC. Yes, it is distributive over addition. Multiplication matrices multiplication is distributive over addition. A plus B into C is AC plus BC. Yes, it is. Okay. Right. So this is all that we have about the introduction part of matrices. We will start doing solving questions in it, and with that you will be more clear with the concept part, because solving questions will help you understand it more. So this is the introduction part, and in the next video we will start solving example questions in it.